Welcome. Today, we delve into the extraordinary life of Albert Einstein, physicist, humanist, and icon. This reading deck explores his life, his unique method of thought, and the moral universe that guided him. Join us as we examine the man who truly redefined reality. Beyond the wild hair and the famous tongue-out photo, Einstein is often reduced to a simple caricature, either the science pop star or the absent-minded professor. In reality, his intellect was deeply grounded in a specific time and place. To truly grasp his genius, we must understand the contradictions that defined him: the solitary thinker versus the global celebrity, and the abstract theorist versus the man deeply rooted in his origins. As he wisely stated, the complete picture only comes from understanding the whole. Only the whole. Einstein's story begins in Ulm, Germany, in 1879. Born on March 14 at Bahnhofstrasse 20, he spent only about 15 months physically in the city. However, his family's emotional ties ran deep, with 18 cousins remaining as rooted members of Ulm society. He himself acknowledged this connection, writing in a 1929 letter to the Ulmer Abendpost, "I look on Ulm with gratitude, as it combines noble artistic tradition with simple and healthy character." Einstein was far from a traditional child prodigy. He spoke with a slow, deliberate cadence, pausing thoughtfully before speaking. He detested the rote learning prevalent at the Luitpold Gymnasium. His genius wasn't about speed, but about an intense, almost obsessive curiosity. We can trace this from an early age. At 5, he was fascinated by the invisible force moving a compass needle. At 12, a geometry book became his holy text, and by 16, he conducted his first thought experiment, imagining chasing a beam of light. He once remarked, "It is almost a miracle that modern teaching methods have not yet entirely strangled the holy curiosity of inquiry." 1905, often called his annus mirabilis, or miracle year, saw Einstein, a 26-year-old patent clerk with no lab or university affiliation, publish 4 groundbreaking papers. First, he explained the photoelectric effect, showing that light behaves as particles, or quanta, laying the foundation for quantum mechanics. Second, he provided experimental proof of the existence of atoms through his work on Brownian motion. Third, his theory of special relativity resolved the conflict between motion and electromagnetism, demonstrating that time itself is relative. And finally, he introduced mass-energy equivalence, encapsulated in the iconic equation EMC, proving that matter can be converted into energy. Let's dive a bit deeper into special relativity and the speed of light. Classical mechanics, established by Newton, stated that velocities simply add up. However, Maxwell's electromagnetism posited that the speed of light is constant for all observers. Both couldn't be right. Einstein's brilliant insight came from a thought experiment: if you chased a light beam at light speed, would it appear frozen? He realized the answer was no. The speed of light is constant, regardless of the observer's motion. This profound realization led to concepts like the relativity of simultaneity, changing our understanding of time and space forever. Now, for a bit of Nobel Prize irony. While Einstein is synonymous with relativity, the Nobel Committee found it conceptually dazzling but institutionally uncomfortable. So, he received the 1921 prize, awarded in 1922, specifically for his work on the photoelectric effect. This was a crucial discovery, demonstrating that light isn't just a wave, it comes in discrete packets called photons. This groundbreaking work laid the foundation for quantum mechanics, a field he would later famously debate, expressing his discomfort with its probabilistic nature. From 1907 to 1915, Einstein experienced what he called the happiest thought of his life, leading him from special cases to a general theory. This was the equivalence principle, which states that locally, you cannot distinguish between a gravitational field and uniform acceleration. Imagine being in deep space in an accelerating elevator. The sensation of weight is indistinguishable from standing still in an elevator on Earth where gravity pulls you down. This profound realization was the cornerstone for developing general relativity, which describes gravity not as a force, but as the curvature of spacetime itself. From a philosophical perspective, the equivalence principle is more than just a physical observation. It functions as a criterion of identity. It establishes the conditions under which we judge the motion of a freely falling frame to be identical to the motion of an inertial, or Lorentz, frame. The critical implication here is that gravity isn't a force acting on a body. Instead, a body simply follows a straight line, known as a geodesic, within curved spacetime. This principle forces us to identify two seemingly distinct states as fundamentally the same thing, revolutionizing our understanding of the universe. The proofs and applications of general relativity have profoundly impacted our world. In 1919, during a solar eclipse, Arthur Eddington observed starlight bending around the Sun, precisely as Einstein had predicted, confirming that spacetime is indeed curved. 10 years later, in 1929, Edwin Hubble confirmed the expansion of the universe, correcting what Einstein had called his greatest blunder, the reintroduction of the cosmological constant. Today, general relativity is not just theoretical, it's practically applied in global positioning systems, or GPS. Satellites must constantly adjust for time dilation, which is about 7 microseconds per day, due to general relativistic effects. Without this precise calculation, our navigation systems would fail within minutes. The rise of Nazism in Germany had a profound impact on Einstein's life. In March 1933, as the Nazis seized power, he resigned from the Prussian Academy and renounced his German citizenship. In his hometown of Ulm, Einsteinstrasse was chillingly renamed Fichtestrasse. The human cost was immense. While Einstein managed to escape, many of his family members in Ulm did not. Lena Einstein, Bertha Hofheimer, Marie Wessel, Hugo Meuse, and Julius Meuse were all tragically murdered in the Holocaust. Einstein's resolve was clear: I will only reside in a country ruled by political freedom, tolerance, and equality of all citizens. Einstein, a lifelong pacifist, found himself in a deeply conflicted position regarding the atomic bomb. The context was grim 1939, with widespread fear that Nazi Germany would develop atomic weapons first. In response, Einstein signed a letter to President Franklin D. Roosevelt, urging the U.S. to accelerate nuclear research. This pivotal act ultimately led to the Manhattan Project, though, ironically, Einstein himself was excluded due to security risks. He later expressed profound regret, stating, "Had I known that the Germans would not succeed in developing an atomic bomb, I would have done nothing." Even in Princeton, Einstein remained a committed humanist. He was an active member of the NAACP, corresponding with W.E.B. Du Bois and famously calling racism a disease of white people. In 1952, he was even offered the presidency of Israel but humbly declined, citing a lack of natural aptitude and the experience to deal properly with people. In his daily life, he was known for his walks to the Institute for Advanced Study, often without socks, deeply engaged in conversations about the fundamental nature of reality, always seeking deeper understanding beyond the purely scientific. Einstein's life ended with an unfinished symphony, his quest for a unified field theory. His goal was to find a single framework to connect gravity, as described by general relativity, with electromagnetism. He dedicated the last 30 years of his life to this pursuit, often isolated from a physics community that had largely moved on to embrace quantum mechanics. This led to his famous debate with Niels Bohr, where he famously declared, "God does not play dice." Today, his legacy lives on, with modern physics, including string theory, continuing this profound quest for a unified description of nature. You can even see some equations from his later papers here. Einstein's deep connection to his origins was later acknowledged. Post-1945, Ulm renamed the street back to Einsteinstrasse. While he responded to birthday wishes, he never returned to his birthplace. Ultimately, Einstein's enduring message, and the core of his philosophical approach, was the unity of nature. As he reiterated, the complete picture only comes from understanding the whole. Only the whole. Albert Einstein, from 1879 to 1955, left us not just with groundbreaking science, but with a profound call to understand the interconnectedness of everything.